So I think we can start now. So welcome all to the IEEE PMRC 2021 panel on global view on 6G. My name is Mikko Uusitalo, coming from Nokia Bell Labs, leading radio research department there, and here mainly in the role of leading European 6G flagship Hexa-X. So we have excellent panelists today from all the regions. We have Jilin Ini from China Mobile, chief scientist there on wireless technologies. We have Maria Matimikko from the 6G flagship research project flagship in Oulu, coordinator of the 6G flagship research and senior research fellow at CWC. We have also Gunnar Mild, senior expert radio network architecture at Ericsson Research in Sweden. And last but certainly not least, Brian Daly, assistant vice president for standards and industry alliances, AT&T USA, as well as in a significant role in NextG Alliance. So in our panel, we are looking at the global view on 6G. So wireless technologies are central for society and economy, and we expect their importance to grow. Wireless technologies should be sustainable and help other sectors of society become more sustainable. Next big thing in wireless is 6G, and here we are giving you the global view on 6G. So let's proceed with the videos and the initial presentations, and please don't hesitate to bring up your questions in the Q&A. Thank you.
Hello, I'm Mikko Uusitalo, coming from Nokia Bell Labs Finland, leading a radio research department there. And here today, I'm mainly in the role of leading European 6G flagship project Hexa-X. And let me share some slides and tell about our approach towards 6G. So, yes, Hexa-X is the European 6G flagship project, and in our vision, we are looking at the three worlds. We are looking at the human world, us humans, about the physical world, about digital world, and we are seeing that 6G should connect these three worlds with the fabric of 6G key technology enablers. So humans, us, we need to be in connection with the physical world, with efficient human-machine interfaces, other means to be controlling in real time the physical world. So for this we need connectivity. Also, connectivity is needed to have updated, synchronized models of humans in the digital world, enabling then, for example, preventive healthcare to predict heart attacks before they take place and act when one can, as soon as one can, to overcome the heart problems. Then we also need a connection between the digital and physical world to maintain exact models of the physical world in digital world for more efficient operation of the physical world. So based on this vision, we have made work on identifying use cases for 6G, and on this and many other things you can find more information, for example, from the Hexa-X website. So if we start from looking at these use cases structured into use case families, and from the use case family, sustainable development. So we need sustainable 6G, and we also need to see how can we use 6G for sustainability. We need to be prepared for additional use cases, so that use case family here in the center low. And then moving forward, use case family massive twinning, so building massive models, taking to the concept of digital twin to the next level of building large models enabling more efficient planning, design, and operation of large physical entities like cities or industrial complexes. Then moving to the use case family of telepresence, so having a person or set of persons interacting with the human or interacting with the machine or set of machines independent of the physical location, using all relevant senses, interacting also with, for example, objects only existing in the digital world. Then moving to the use case family, robots to cobots, so how to have a machine or set of machines collecting information and helping human or set of humans in the best possible way in the actions of those humans. And then several various use cases focusing on local trust zones. Then we have identified several research challenges that we need to overcome, and more information on this also on our website. And then we are looking at which technologies we need to study in order to reach then these research objectives and research domains. So in order to provide more capacity, we need to look at high frequencies, but at the same time need to pay attention to what can be done on low or mid bands. We need to look at new technical opportunities, for example, related to localization and sensing, and we need to look at the AI/ML as a fundamental new base for 6G and many other relevant technologies. We are a very strong consortium, Nokia in the overall lead and Ericsson as technical manager. Top operators, so Orange, Telefonica, Telecom Italia contributing, vertical, Siemens, and many other technology providers, as well as top academia. So we are the European 6G flagship project, building the base for larger set of projects starting most likely next year in the smart networks and services. And here in the panel, we are enlarging and getting interaction with the other regions of the world of looking at the global view on 6G. So at the moment, in terms of 6G, we are in the time of structuring and framing, moving towards systemization research project in the next wave, halfway through the decade towards standardization, and then end of the decade to commercialization. So thank you. This was the summary and a beginning for then thinking about the global view on 6G.
Hello, my name is Gunnar Mild. I work at Ericsson Research. I will participate on the PIMRC 2021 panel called Global View on 6G. For the last 20 years, I have been involved in research and standardization on mobile communication technologies, including 4G and 5G. My focus areas has been on radio network protocols and architecture. Currently, I'm involved in 6G research activities targeting mobile systems in the 2030 timeframe. In 2030, it's expected that society and industries will be even more dependent on communication systems when it comes to delivering reliable, high-performance connections. The journey towards these systems is starting now in 5G, addressing industry's needs for communication in local scenarios such as factories, ports, smart cities. In 2030 timeframe, it's expected that reliable and predictable real-time communications is needed everywhere, including also wide area scenarios. This will put requirements on how networks are designed and built to provide guaranteed performance in challenging radio environment and providing redundancy mechanisms, etc. Additional driver for 6G is new communication services, including immersive communication, AR/VR, as well as new communication between intelligent machines, which potentially can go beyond the requirements of current human-centric communication. Finally, we suspect that sustainability and sustainable development solutions will play a large role driving the communication systems in this time frame. I'm looking forward to participate on the panel and discussing these topics further. Thank you.
Hello, I'm Brian Daly, the Assistant Vice President of Standards and Industry Alliances at AT&T. I also serve on a number of industry organizations, including co-chair of the NextG Alliance Steering Group. Almost a year ago, ATIS began discussing the critical need for North American leadership to develop a robust 6G market by the end of this decade. North America has long been a leader in driving innovative solutions to market and creating an equal playing field where industry can compete and deliver powerful solutions. As we look ahead, 6G represents an even greater opportunity to extend wireless solutions into almost every facet of human and machine interaction. To ensure the realization of this ambitious opportunity, ATIS developed the 6G Call to Action, a blueprint for industry, academia, and government to collaborate on a strategy not only to move, but to accelerate toward the realization of a North American vision for 6G. In late 2020, the Call to Action led to the formation of the NextG Alliance and a commitment to build the foundation for North American leadership in 6G and beyond. With strong support from the ATIS Board of Directors, government, and the ICT industry, ATIS launched the NextG Alliance along with its founding member partners. Although the NextG Alliance was launched as a private sector initiative, its primary objective is to influence North American government and research communities. While it is indeed true that every company, institution, and research community must develop its own business strategy and unique product portfolio, the power of a collective vision is a core principle of the NextG Alliance. But this vision is not simply a view of a set of recommendations captured in a document. The NextG Alliance will drive actions across a broad range of areas, including policy, funding, research priorities, and core development areas. We have seen the NextG Alliance grow quickly, starting with full members and more recently adding contributing members, which include leading research and academic institutions, smaller specialized companies, and research communities. Likewise, as the NextG Alliance launches its working groups, participation has increased to over 500 technology experts and thought leaders from industry and academia. The NextG Alliance will continue to grow and expand into new areas as its comprehensive work program is developed further. We must establish 6G and beyond, which we characterize as NextG, as a national agenda priority. Increasingly, we are seeing initiatives around the globe to drive further competitiveness and economic success in their geographies. And that is the reason why we are here today. The goal of the NextG Alliance is to bring together the best minds and the best ideas to firmly establish 6G as a North American priority. Next, we need to develop the best suited model for the North American landscape. While technological solutions and standards may be defined at a global level, regional differences and opportunities must be addressed in terms of societal drivers, geographic needs, vertical market approaches, government priorities, and many other factors. Finally, collaborating on a future 6G vision will establish a robust North American marketplace for the next decade and beyond. Ensuring a vibrant marketplace for more than 300 million North American mobile subscribers will also strengthen and enhance the ability of North American companies to fully capitalize on their leadership in the broader global 6G market. Thank you very much, and I appreciate your attention.
Good morning. This is Qilin Yi from China Mobile. It's a great pleasure to join this very timely panel with the distinguished colleagues here. First, in the past, I guess, more than 18 months, or going to be 2 years soon, globally, we have all been impacted by the pandemic. But actually, in China and some other regions, you will see that the pandemic did not really slow down the development of 5G. On the contrary, in a way that it accelerated the 5G deployment in some of the regions. We have seen how the value and the power of 5G gets showcased, and it is an essential element that helped ensure that a new way of life was enabled. It includes the new way that we live, we learn, we work, we entertain, we govern, and even staying safe. Okay, and in China Mobile, during this period, we actually have deployed already more than 500,000 5G base stations covering the whole country and serving around 280 million 5G subscribers at this point. That is a very high percentage among the 900 million total subscribers that we are serving. And in addition, in terms of serving the verticals, China Mobile has already developed or pioneered more than 200 nationwide headquarter level projects, and has deployed at more than 4,000 at this point, provincial level and with regional characteristics projects that covers 5G enabled smart mines, smart ports, smart grid, smart city, smart campus, smart hospital, etc. And it actually encompasses over 18 industry sectors. However, of course, this is still the very early stage of 5G promise of transforming our society. And in the meantime, since 2018, when ITU launched its focus group of Network 2030, exploring the use cases and potential requirements of 6G era, globally in various regions, including Europe, North America, and Asia, that covers Japan, Korea, and of course, China, various platforms to collaborate on early stage 6G exploration, as well as various national or regional major key R&D projects targeting 6G advanced research has been launched. And in China, IMT 2030 promotional group was officially established in 2019, and in 2020, a large set of national key R&D projects for 5G was initiated. And then this year, in June, IMT 2030 promotional group has released its first white paper on 6G vision and potential key technologies. And of course, when it comes to the key technologies, I think globally there's a lot of similar interest in a set of the potential key element that would be the ingredient of a 6G system. I'm listing some of them here: terahertz, reconfigurable intelligence services, and space, air, land, sea integrated coverage, communication and sensing capability integrated system, digital twins, connected intelligence, etc. So it's probably gonna be covered in the rest of the discussion in this panel. But I do want to actually highlight a very important theme that is underlying where we are, because we really are in the middle of a very important, very unique, revolutionary evolution journey in the history of our mobile industry. Up until 4G, all the way from 1G of our network, basically communication technology evolution was the main force that drove the upgrade and new generations to be initiated. But from 4G to 5G, we actually have enjoyed the real true ICT convergence, IT and CT technology convergent. So to enable us to jointly pursue the efficiency, green, and agility and soft. And going forward from 5G to 6G, we see the accelerated deep convergence of ICDT deep convergence that bring us a new theme, a new set of theme on top of the green and soft, which is open and smart. And I think this whole journey from 4G through 5G to 6G will be marked a very important paradigm shift transformation of our whole industry. And so a little bit of reflection, basically we on our way from 5G to 6G, we are actually going through the ICDT convergence, going from green and soft to open and smart. In this, it would be characterized by native intelligence in 6G, full disaggregation in 6G, and the value of a true open ecosystem globally will bring forth the advantage in cost, efficiency, flexibility, ability to have fast innovation. And more importantly, I also want to highlight the very interesting new dynamics we have observed, and we believe that by mixing the traditional standard development organizations practice with open source community and with the element of machine learning and AI as the key ingredient, we should see agility injected into our future standard development work. And then a few words about initial thought about 6G, even though I think we will have a lot of discussion in this panel later on, but I think the social goods will be keywords. We talk about sustainability, and we talked about enabling sustainability as well as the 6G itself sustainability. But I think for all of us, we also need to think about what we really should have, what we really need going forward. That is what's must have and nice to have, or what we should have, or I mean, we should not have. I think this requires a lot more work than all of our previous generations. That's very unique for 6G. And then some other thoughts, just one thing I want to highlight, which is the operators, where we come from, and also my colleague, Brian from AT&T. I think we also need to think seriously about what kind of the mainstream of MNO will become in the 6G era. Is MNO with the full end-to-end network still be the norm? And judging from the recent development globally, I think there's a big question mark here. So will MNO morph into some sort of a new digital service operators, cloud operators, or resource brokers? I think there's a lot of thinking that we also needs to pay attention to. And of course, I think without a question, data ownership will be a big thing in the 6G era. And so finally, I want to share with you the keywords that China Mobile has in their 6G vision, which is digital twins with pervasive connectivity with ubiquitous intelligence, okay? And then we can all expect in the 6G era, our experience will be much more immersive, intelligent, and ubiquitous. But how much more? How do we quantify that? And what kind of the KPIs would we need to work towards, or maybe some multiple dimension joint KPIs? There's a lot of interesting things to think about for 6G. And so thank you very much for your attention. That's all I'm gonna start with today. Look forward to a great discussion. Thank you.
Thank you. Shall we then move to Maria?
Hello, Mikko. My name is Maria Matimikko Blue, and I come from here, University of Oulu. I work in the 6G flagship research program. And I'm giving some ideas of what we've been doing about 6G vision building. And many of you, I believe, have been involved in our activities. So global view, and Mikko had a great set of questions that we'll be answering later on. But just to start from this vision work. So we started this 6G research in 2018 at the University of Oulu in 6G flagship, and we built a vision for the year 2030. And now we revised it when we realized that sustainability is the single most key driver of this whole development. So this revised 6G flagship research vision for 2030 is that our sustainable future society will be data-driven, enabled by near instant and unlimited wireless connectivity. And as many of you know, we made these white papers, the world's first white papers. There's 13 of those where we looked into those different aspects that we consider relevant for the future 6G vision. And now this vision building is also continuing elsewhere. So there are many initiatives like you've seen, and also the ITU at the highest level has started the IMT for 2030 and beyond vision building and technology trends work. So it's really, we are now at the time of this joint vision building. And then thinking about what is different this time. Many of us have been doing this for several rounds. Now it's 6G. But what's new, what's different? And I want to emphasize that we've talked about green communications for 4G and even before, but the real sustainability part is yet to come, and it has to be the key driver in 6G. I looked at the ITU work on the prior generations, and clearly sustainability was not there yet, but now it will be in the future work. And then another key thing that is changing the ecosystem, the landscape, it started in 5G, this emergence of a large number of locally deployed, locally operated mobile communication networks, often private networks. That has started. There are local spectrum is being made available in many countries, including Finland. So this is a big game changer, and it also leads to these different roles of operators and so on. And sustainability, it has to be looked at from many angles. What we can do to help other sectors to transfer operations, but also our own impact. So whenever ICT researchers or other people do their work, they have to consider what sustainability means for me. For me, I do research on spectrum management, so now I look into what sustainability means in the context of spectrum management. And we did the world's first white paper about connecting 6G with the UN SDGs. A starting point, it requires so much further work on this role of ICT in the UN SDG framework. And we made this bold suggestion that we could use those future wireless networks as collector of data, of data for the different indicators in a very local granularity level. It's really difficult today to collect data for the SDG indicators, but how to use the ICT networks to provide that data and use that as one design criteria for the future networks. And why do we do this? People, the end users, we talk about machines being end users, but it's really people out there in the different parts of the world. They have different needs, and that they must be integrated very early on into the 6G design. And finally, the business ecosystem. Nobody knows what the 6G business ecosystem will look like. But what we know about that is that the stakeholder roles are already changing. There'll be new stakeholders, existing players change their positions, the roles will change. There'll be a lot of different resources provided by different stakeholders, different users, end user needs, verticals, humans, and then different roles for brokerage, matching these needs with the resources. The same need, for example, communicating from here to somewhere else can be provided with different resource configurations, and that complexity will just keep increasing. And that is about the stakeholder management, how to make those voices heard who are not yet active in the process, those who are not in the dominant market positions. We have to involve them early on when we start this, when we have started the 6G research. And that's where research organizations like us, we play a role in providing these, facilitating these stakeholder interactions, bringing different players together, and that is really even what this event is all about. So then there's some further reading that you can see And I'd like to stress that these white papers, now there was the time to make those. And it's good to see that there's also a lot of activity now in the research domain about those individual research topics of the selected 6G themes. We made these lists of questions for further research, and now there's a lot of activity to actually address those questions. So thank you.
Thank you. Thank you, Gunnar, Brian, Chilini, and Maria. So we have a good start. And let's then discuss more among ourselves and, of course, pay attention to the chat. So especially I pay attention there that if we get additional questions there. So as a starting point for the panel, in the initial information, there were 5 questions, and part of the answers were already heard in these beginning speeches. But we could anyway start from those and maybe add something. And some of the panelists didn't yet go very much to those. So starting from this 6G vision and top 3 use cases behind that related to this. So anything to add from any of the panelists? How do you see vision and top 3 use cases?
I can start maybe. I hope you hear me. So I think that my vision on this are covered by some of the presentation. I think 6G should be a system that is fully trusted, reliable. It should be available everywhere and all the time when needed. There shouldn't be any limiting factors and so on. So I think that was kind of reflected also in other presentations. Regarding the use cases, I think that these immersive use cases are very interesting. It could be, I think there's a use case family there of use cases like telepresence, being able to remotely explore a new environment, interact with people as if you were there. And I think this is also related to merger between reality and cyberspace, VR, AR type of use cases, which a really good thing here, I think that they can have a usefulness in many different areas. They could be used in sports and entertainment to give a really immersive experience, but they can also be used in education, communicating, collaborating with other people, and also kind of enhance the human senses, that the humans can see what's beyond the hill or get up knowledge about what they see in a very easy way. So I think they are very kind of interesting in that sense, that they can be useful in many different scenarios in work and society. I think they're also very technically challenging. I think maybe some of these use cases will start happening now in 5G, but there's probably some of these use cases that may require more requirements on the network. I think another use case family that is quite interesting is this having these critical services. I think critical services was part of 5G, and I think 5G is targeting this area, but it's mainly focusing on maybe local use cases or in a bit more of a controlled environment and so on. And I think that in the long term, society, industry will have more and more trust in the networks to even provide very critical services in a wide area and so on. And this is more challenging because the radio environment is varying a lot. But there will be requirements on having predictable latency, guaranteed throughput, very high service availability and resilience and so on. If something goes down, you should still be able to operate. And I think this is an interesting area for 6G to work on. And this could then enable industries to really trust the network to handle critical remote control use cases, alarms, and so on. Then the third area I think has also been into is about sustainability, sustainable development. How can the system be a good force in the world? And I think you have been into covering these things. I mean, it's about us as an industry reducing our impact on the society, but on negative impacts, and then also about helping other industries to reduce their waste, to reduce their CO2 and so on. But I think we should see it as very broad. It's also sustainable development. So it's about digital inclusion, ensuring that people even in remote areas have access to digital services at a low cost. And this could be related to having sort of global service coverage and so on, which I think could be an enabler for more use cases in remote education, healthcare, and so on. I think these things are happening today, and a lot of these use cases can be supported by even 4G, but I think they will become more and more important in the 2030 timeframe. And so the complete system with 4G, 5G, and 6G should be able to address all the needs in this area. So I think those are three of the use case families I thought of. There's of course many others.
Thank you, Gunnar. I think Maria also already covered quite much these questions about anything, Brian or Gillian, you would like to add to this, or shall we? How do you see it?
Yeah, hi, this is Brian. I'll go next. So when I think of 6G, there's really two aspects that I would consider. The first is the continuous ongoing evolution of the current 5G technology. We have enhanced mobile broadband, massive IoT, and ultra reliable low latency communication as the three pillars of 5G technology. We'll continue to see that evolution as we progress through this decade and into the next. And certainly we'll also have more radical steps with a new generation of technology, both on the air interface as well as in the network, that will take that ongoing evolution to the next level. With that, certainly we're going to see new use cases emerge, both with the evolution of 5G as well as the introduction of new technology in 6G. As Gunnar mentioned, we'll see multi-sensory telepresence and immersion. Extended reality services, we've already started to see the light of those in current 5G systems. We're seeing, new full view 12K video, for example. But as we progress forward, we are going to see systems that incorporate the 5 senses into the XR experience that will require higher data rates than we even have today. The XR services, as we look at them, we see virtual reality, augmented reality, and mixed reality systems. The goal is to give users a sense of absolute presence and immersion by providing this artificially produced environment. So I think as we move forward, more immersion and a more augmented reality environment is going to be one of the highlights we see as we both extend 5G and move into 6G. The other area is Industry 4.0. We've talked about the ability to provide ubiquitous computation and communication and systems with the end goal to mimic human behavior or make decisions in environments that require human interactions. Some example of these would be self-driving cars, autonomous robots, socio-robots, etc. We're in what I would call the fourth industrial revolution now. We have the cyber physical systems that are being enabled by wireless networks. Industry 4.0 has also been referred to as a smart factory, where we have an industrial environment that can run either semi or fully autonomously. And this will give the ability to collect information, share information, and use that information to be able to make better decisions and be more productive. And you know, I think that's really important. The other area is the verticals, and you know, we're starting to see more vertical development in 3GPP release 17, for example, and that will continue on as we progress forward. 5G systems have caught the interest of many specialized vertical industry sectors. This trend is going to continue, especially in areas such as agriculture, automotive, healthcare, smart factories, smart cities, education, media, and entertainment. You know, those are just some. And especially smart agriculture and livestock, as we, you know, move forward and the need and demand for agriculture production increases, we're going to see, you know, simple IoT devices spread out over farms, so that farmers can reduce waste and enhance productivity with the ability to monitor field conditions from anywhere, and also have automated machinery to perform whatever actions are needed. This will give farmers the ability to foresee production output, and allowing better production distribution. And I think, you know, again, this is a great need and will, you know, have a high impact in society in general. And transportation in general, again, moving toward the autonomous vehicles and swarm systems. There's V2X technology being developed within 3GPP now. And again, as we move forward and move more intelligence into the network, I think we'll see those increasing more. And again, vertical supporting first responder and emergency services, as we look at the high reliable, high available, and resilient networks. Again, that's going to be another area. And I also mentioned medical and healthcare. Certainly, the ability to obtain medical review and advice from their homes. We've seen this during the pandemic, the need for telemedicine. And I think as we increase and provide biosensors that will able to provide more health information, I think we'll see that again increase as we move into 6G. So those are just some of the thoughts and ideas that we see on the horizon. And again, looking at both the evolution of 5G as well as the transition and radical technology changes as we move to 6G. Thank you.
Thank you, Brian.
Okay, yes, Mikko, thank you. I think our colleague had already elaborated quite extensively, so I'll try to be brief here. And the thing is, I think up to 4G, we used to look at each generation as a generation that has a revolution in the air interface, right? But going from 4G to 5G, we already recognize that it's no longer the single most dominant aspect that differentiate the 5G from 6G. It's not just the air interface. It's actually the end-to-end architecture. And that change, that revolution comes from what I think I try to highlight, that a true IT and CT convergence, the ICT convergence that brought us to that fundamental difference in the end-to-end system in 5G. And also another remarkable difference in 5G era because of that ICT convergence that brought us, I always like to say, not only the efficiency for being green, but also the sustainability and also the agility for becoming soft. In a way that it enabled us to build 5G not as before every new generation, it was a yet more powerful horizontal platform, primarily looking at the general public, like common folks like us as the primary audience or user. It actually the 5G is the network that for the first time that not only continue turbocharged the universal horizontal platform, the network, but also brought in the capability of the coexistence of multiple vertical slice of the network, and every vertical pieces would match drastically different needs of very different vertical industries. And I think 5G opened the door of our network, our system, not only considering general consumer users as the primary target, but really officially brought in all of the different vertical industry. Like I think Brian tried to highlight some of them, okay? Be it the health industry, education industry, agriculture, and manufacturing, and the smart city, the transportation, all of the different aspects that impacts the whole society are all included. However, of course, with that vast mission, no way we could complete it in one generation. And we know that the 5G at this point are in the standards is in really, I think in release 17. So from the 15, 16, 17, these three releases are together will complete the initial set of the goal of 5G, whereas the release 18 that's being in explored right now, the planning of release 18 has started. Release 18 and release 19 are going to compose of what we call beyond 5G or 5G plus stage. And that will be a very important transitional segment before we started going into the official 6G standards exploration work. So I think in this stage, the second phase of the journey that I try to highlight, which is bringing DT element, the data technology, bringing in embedded intelligence into the future in our system, in the capability. This is going to be the key differentiator going from 5G to 6G, okay? And here, I believe it will enable us to continue perfect the vision, the mission, and the goal that we have set out for 5G, which is transforming the society. But it's gonna take more than one generation to do that. So, so in a way that I think, yes, for consumers, the immersive experience, whether it's AR, VR, MR, or XR, okay, all of this will continue to evolve. But in the process, I would like to also remind everyone to think carefully about with this capability, what valuable services and applications that we are really shooting for. One of the things that I kind of continuous, I don't want to say discourage my team member, but I don't want to encourage my team member to continue explore is how to use this technology to just enhance our entertainment capability. Gaming, for example, it is a big business, but really that's not the reason why we continue to improve our network and system, right? There's many other much more valuable application services we should think about. And that's what I was trying to say about both the society good and also for the individual health all around. And I think this is something that we need to think carefully. 6G at this point, it's a very early stage. Actually, think about 10 years ago, okay, 2011. Were there any book that titled with 5G on it? And if you go look on the web right now, you will see, if not 10, at least half a dozen or more books that has been already published. Books, okay, it's not an article or a white paper. We're talking about books. There are already more than half a dozen books with 6G front and center in the title. So it's great that on the one hand that we have started thinking about it so early, but I would also want to remind everybody to not think 6G is something that would pop out as a completely disconnected phase or era in our life. It's gonna be a continuous, evolution. It's a revolutionary in nature, but it's revolutionary evolution. So I think we have a lot of interesting things to see in terms of technology and also our global ecosystems involvement in this period. Okay, I think I did not answer your question directly. I did not give you use case 1, use case 2, and use case 3, but I hope I have kind of give you the essence of my thought at this early stage of exploring 6G. Thank you.
Thank you, Gillian, and thank you all. So great comments. So before going forward in the basic set of questions I posed earlier, so we have actually several questions in the chat, so let us look at those. So Arnes Vijay is asking from us that about like other forms of technologies, especially highlighting visible light technology, Li-Fi. So any comments from the panel about incorporation of visible light technology into 6G radio technology, and if you see that, so which use cases especially would there be valued, and what kind of challenges you see on this road? So any comments from panelists on this question?
Let me jump in first this time. I think VLC has been a very interesting topic that we've been exploring, not just because for the sake of 6G, actually we explored it for the sake of 5G as well, or even earlier, maybe not so prominent, but I think it has been a very prominent direction that the global research industry has been looking at. And the thing is, there are several, I think, not so well-known condition about VLC. The top of it is that, yes, we look at the light wave, we think, oh, there's such a broad spectrum, right? Potentially very high data rate, very broadband connectivity could be provided. But really, the spectrum is there, but we don't have the device for it. I think my understanding is currently the VLC or the Li-Fi device is bandwidth limited. So it does not bring forth a very broadband connectivity compared to what we can do in our regular spectrum. Okay, at this point, it's because of the device. So we need some breakthrough in the device technology, which I'm not expert in. Okay, and the other thing is, I believe, in a way, it should be a good complement to our network as a additional downlink pipe wherever it's suitable. But the uplink for using Li-Fi is gonna be very challenging as part of the constraint in the architecture sense. Okay.
Thank you. Any? Gunnar, were you planning to say something, or?
Yeah, I think it was very good comment from Gillian. I think that, I mean, I think it remains to be seen if it's an interesting technology. I think we have the capabilities to integrate it into with the radio systems. I think there's a lot of experience there. I mean, we were able to integrate LTE and 5G. We have integrated Wi-Fi and so on. So it is definitely possible to do, but I think it remains to be seen how big role it can play and so on.
If I can continue from this, I think it's important that at this stage we encourage the technology development, largely different technologies. Because when you consider one technology, you can make innovations there that you can then duplicate elsewhere. So when we were there in 4G and 3G, we saw different candidate technologies. 5G, we see very few. So overall, it's just the difference. There should be some level of competition to innovate, to make people, the engineers, innovate towards the best solutions.
Thank you, Gunnar and Maria. Brian, do you recognize any need to add something to that?
No. I think generally agree with what Gillian mentioned, and and the other panelists. So nothing more to add.
Yeah, thanks. So then Chengfei Tang is asking that There are great ideas in the panel, and asking that whether there is any fundamentally different radio technologies compared to 5G below 100 gigahertz spectrum for 6G. And I certainly think there are, but I have several answers to this, but I let the panelists move first if they want so.
Let me try throw out a couple. Not that we are certain it will fulfill some the promise, but one has been explored by our team locally a lot is the faster than Nyquist air interface technology. Involving in overlapping signaling in potentially time domain, frequency domain, or some other domain. So far, however, there are two camps of beliefs. One is that this potentially is a mean to justly improve the spectral efficiency compared to the traditional approach, but the other camp thinks absolutely not, because there is some implied bandwidth expansion using this technology that needs to be taken into consideration. So once you normalize it, there is no increase, okay? So this is one thing that I, based on our team's experience, I could share. The other one is a thing that we actually started exploring quite early on, even in the 5G research era, which is still a continuing pursuit, which is what we call the transform domain technology, where our traditional system works in time and frequency domain. Okay, now the transform domain actually involves instead of frequency, design our system in the elastic domain, a subset of the two of this. So when you transform it, for example, with the design in the Doppler domain, you will see that the fast-moving vehicle became much more stationary in that transform domain. So it's a lot easier to handle and to design and to.
There seems to be a bit connectivity problems, and looking at the reaction from others, it seems that between the others, the connection is moving forward. So I'm sure we get Zilin soon back online. But any additions from other panelists? Maybe.
Yeah. Hi. This is Brian. Let me just, if I may. So I think one of the areas that we need to look at is addressing, some of the technical challenges that we're seeing to evolve the 5G millimeter wave sub-terahertz and densified networks. Certainly we'll see the evolution and advances in these systems, especially to when we support a large number of antenna elements, which will give us narrower beam width beams. We need to consider form factor in the user equipment through the die size, power, thermal, real estate challenges that we would have. Just looking at various technologies in order to look at making the current radio technology more efficient, bringing in machine learning, AI-based beam management approaches, for example, could be one area that's currently being researched as well. And also, looking at UE power consumption. As we have more and more power demands of millimeter wave systems, especially as we're looking at the higher data rates, how do we address higher power consumption, especially within the UE itself? So I think those are some of the areas to look at. as well as, narrower beam widths, how we reduce interference, latencies in beam acquisition, increases, the increase in power consumption and higher thermal overheads. I think these are some of the things that need to be addressed as we progress forward and look at the radio technology. And certainly the densified networks, as we look at the sub-terahertz deployments, looking at technologies such as smart repeaters and relay nodes, and looking at complexity, cost, power, performance trade-offs with such intermediate nodes. We need to have a better understanding of those. And certainly as we densify the networks and bring in artificial intelligence-driven approaches for scheduling, interference coordination, mitigation, beam and link adaptation, for example, these could allow for more personalization and tailoring of solutions for specific user profiles and behaviors. So I think there's opportunities, certainly to advance the radio technology that we have in 5G, and as we move into 6G, into terahertz range, certainly a lot of research areas being done in that area. Thank you.
Thank you, Brian.
If I may,
yeah, please.
If I may add one more thing about this, when we consider radio technologies below 100 gigahertz spectrum, it's a huge variety of different bands with different characteristics, and typically these cellular networks are based on exclusive licenses, and now we're seeing those local licenses, local networks, and that all should lead towards shared spectrum access, and then all those technologies that are needed to make spectrum sharing a reality between different local networks to protect incumbents and so on. So I see a lot of different approaches in terms of this interference management, coordination, and shared spectrum access below 100 gigahertz.
And this is like a field of technology that has been on its way to come at the earlier stages, and there is new development in this area. And also there is the kind of a bigger question, I think Maria is behind as well, that will this now come in a much wider scale in the next generation?
Mikko, can you hear me? Yes. I think I'm back online. Let me just wrap up what I was trying to say, even though I missed the part of the conversation. I'm not sure whether it's already covered. But just to summarize, when you talk about potential new opportunities in the air interface, I covered a little thought about the fast and the Nyquist. The other is the transform domain design. And then the third one, I think everybody has been involved globally in the sense of bringing in machine learning and AI into the next generation air interface design. So whether it is use that technology to enhance certain key modules in our transceiver chain, or is it possible that by 6G era, we're gonna have a whole end-to-end design? That's probably not likely, but I think the academic community is very diligent on that pursuit. So it will be interesting that going back to one of the elements that I was trying to share, which is I think there will be a lot more agility in the 6G standards development because of the presence of the AI machine learning technology, but also because I think the open source community will be playing a very interesting, a holistic transforming role in the 6G era to working together with the standard development organization. So I think it would be very interesting to see how that would impact the air interface design in the 6G era as well, in addition to the network architecture aspect. Okay.
Yeah, thank you, Jillian. That part was not covered earlier, and I was actually just at the moment planning to share this point of view as well. So good timing. Gunnar, would you like to add something?
Oh, I think for this question, I think it has been answered quite well. I think it is about also being able to use the spectrum in new ways and so on, and also things built on top of things that could be interesting in 6G that it may not be only about the coding and modulation. It's more about the features that we can do on top of things. So yeah, I think there's a lot of things to research here, and there will be very interesting things coming in.
Certainly. One thing I would like to add to this list as well that has not been brought up yet is joint communication and sensing. So with 5G, we have better possibilities for positioning based on the communication technology, and this evolution will move forward and it will be improved. But then there is also the research item that with the communication system, on top of the communication with some overhead that might not always be so big, so we could get other information on the environment, for example, on the location or movement of some bigger objects or some humans or so. And this then could be used in favor of the communication as well as then for other purposes. Yeah. Anything still to add on any of the panelists to this question?
Oh, well, I think it's a very hot topic, right? Integrated or joint communication sensing. I don't have much of detailed knowledge there. However, to think that going forward, we are combining our regular mid and low frequency spectrum technology with like terahertz, then certainly one came from the sensing domain, right? And the other is where we are from the communication domain. So when you marry these two together, how they can complement each other in one system, I think that's a very interesting opportunity to explore. And the other, I guess, the more daring endeavor is trying to use just one, for example, terahertz for both sensing and communication, which I think is a very bold move, and I'm really looking forward to see the development. It's exciting, but I really don't have much knowledge about it. But I'm aware of it being a very interesting approach. But I personally feel that it's probably easier to see how we use the strengths of these two pieces and how to combine them in a complementary way, recognizing that the terahertz devices currently are still, I think, more suitable using it to build sensing domains system rather than a communication. That's my personal opinion. Okay.
Thank you. If we move forward, either questions in the chat. So there is a question from Roger Hoffel about how do you define freedom regarding the effects of 5G/6G networks? And it's not fully obvious to me what is meant here with the word freedom in this context, but just let me read the question once more. So how do you define freedom regarding the effects of 5G/6G networks? Any reactions to this from the panelists?
I'm not sure. I think we need some clarification.
Unfortunately, we have some network problems with Celine.
Here. Exactly.
I think Celine was saying that we need more explanation, and maybe then we can get it to the chat. So now there is more. So the effects on the society of new architectures. So effects on the society of new architectures. So new architectures could then, or most likely in this context, means network architectures.
Well, if I start with the thought that I learned a great thing yesterday's panels, when I was listening to the yesterday's panels, and there was the big discussion on sustainability and what that means, and it means different things for different people in different countries and so on. They're seen differently and different solutions are needed, and I think this is a good thing to think about. We are developing now the new technology. It will be used in very different ways depending on where it is used and by whom. And then it's always a context-specific thing, even the sustainability and UN SDGs, the targets there, how they are interpreted and what they mean in the different places. So regarding this freedom, I think freedom is also the choice of not using something or not doing something, or freedom of choosing how you use something, how you use new technology and new services.
Yeah, for sure. I think, I mean, we recognize the regional differences of priorities. And so I agree with my colleague that whether it's sustainability or choice of use, I mean, there's certainly it's up to the local society and the individual user. The choice is always in the user's hands. I think no one should be forced to use or not use the facilities or the capabilities that 6G era system is providing. I think that it's definitely the general philosophy here. I hope that we both have kind of addressed the question that Roger, I think, the one that brought up the question.
Thank you. Good answer. So anything to add? Or if we move forward with the questions, so one question to raise is that what would you define are the top capabilities that 6G should provide? So we did hear something in the beginning, but something to add to that by any of the panelists.
I could add a little bit. Oh, sorry, go ahead.
No, go ahead. You go ahead.
I think I actually connect to you one of the capabilities I think you brought up, which is about agility and being able to. And the way I interpret it is that we should be in a position where we can introduce high impact changes and new features on the system in a very efficient way. And to me, that means that we should have a system that we don't have to go through a long standardization process or integration testing process to be able to try out new features. And I think this is really a challenging area. I mean, there could be solutions around having sort of downloadable AI agents that you're training and you're able to update those. Or it could be about having software components that are deployed both in the network and maybe even in the devices that can enable new features and so on. But I think it's also about finding the right balance on what you standardize. There is, of course, a very strong need to have good multi-vendor interfaces in place, but those need to be designed in a way that we can easily add features. The network vendors and operators can add things on top and deploy customization. I mean, for instance, I think one interesting area is about there's a lot of these industrial use cases that may have very specific needs that are only needed for that particular use case. And today, I think the challenge is that they get one solution fits all. So they need to be a way of customizing for that use case. And I think that's something to think about, how to be able to better do that. And there I also would like to get input from the other panelists on what they think is the best way of enabling this agility in adding new things to the network.
Well, definitely, even though I do think that starting when we moved from 4G to 5G, we have already started bringing the idea of agility. I still remember actually in the around 10 years ago, 2011, 2012, when we first started talking about we need to be both green and soft. We need to not just pursue perpetually the ultimate efficiency in all domains that our industry has been very much accustomed to. We need to learn from our both friends and foes, the OTTs and the other industry, to become much more software oriented, to be softer, so that we can have upgrade and the customization and the new whatever fractional generation that can come out much faster than by counting by the years. And we need to really be soft. Okay, that's where we get agility. And I think 5G standards actually has started that revolution. And even though 10 years ago, it was a very hard concept for our traditional industry to accept. But at this point, nobody questioned about it because it is already a wide consensus. But going forward, I definitely agree with Gunnar that there is still a lot more work to be done, because after all, a global standards organization is required to lay down the common foundations. But even such organization and such effort cannot possibly be able to figure out every single little nuances that different region, different industry, different special segment may require. So there has to be enough flexibility built in our both beyond 5G standards and also the 6G standards that allows the various necessary customization as needed. I think that is definitely a top requirement in the next generation system. We cannot make it very rigid. And I also am confident that we are not going to make it very rigid. Yeah.
Yeah, this is Brian, and just to expand on that, certainly as we're looking at the 5G transition to a more cloud-native, service-based mobile network convergence, we're seeing, a microservice-based architecture as being one of the key changes. Cloud-native technologies are going to give service providers the ability to build and operate scalable applications in a dynamic service environment. And provide, the ability to spin up on the fly and operate relatively independently. And I think that will continue as we move into 6G. The network trends towards softwareization, I think, is going to continue. And also, we're going to see things move, to the edge and more edge-centric and data flow based across the network. We're going to see, that continued, the important dimensions of cloud-based architecture, how they're delivered and orchestrated, the transition to DevOps paradigm, all gives us the agile framework so that we can do continuous delivery and integration of large-scale productions. In addition to that, with communications and compute convergence, we're seeing the coming together of internet, telecom, media, information technologies. This is going to give us a system of interconnected components acting as a global nerve system. And with that, as we move towards 6G, we're expecting to see all physical things into the realm of compute and acting as a connector and real-time controller of cyber physical systems. So we'll see compute storage tightly intertwined with communication as we move forward. And certainly, as was mentioned earlier, the move toward open systems and open interfaces, disaggregation of the RAN, starting with that virtualization of network functions. Again, we're expecting to see that continue into future releases of the mobile networks. And as the open RAN architecture matures and becomes mainstream, we'll see a growing ecosystem that'll drive the exposure of network APIs for edge computing, automation, and other use cases. So those are some additional thoughts on that. Thank you.
Great, thank you. From Maria, we already heard in the beginning answers to this question. Maybe we then move forward with the questions. How do you see the approaches globally? So we have been discussing here from several points of view what's going on with 6G, but at this stage, do you actually recognize any major differences in different regions, or are we kind of roughly agreeing at this stage?
Well, I think at this early stage, we see various platforms being set up across, as I said, in Europe, in North America, and in Asia, various countries. I believe that just like in the 5G era, actually there was this global alliance across the respective regional standards forum that kind of join hands in addition to the collaboration directly in 3GPP. I think that kind of a collegial collaboration will continue. And currently, definitely, I think in addition to what I mentioned, the ITU's early focus group on Network 2030, to its credit, I think the 6G flagship initiative that was originally launched out of the Oulu University in Finland played a big role to bring the awareness and the excitement globally to start looking at 6G. And then all the various platforms that has been set up, be it alliance or promotion group or whatever you call it, across the world. Currently, I believe are all at very early stage, but all had a common interest to collaborate. And actually, I would like to see more explicit collaboration across this platform, and to avoid the danger of somehow we had some segmentation of different regions. So I think I'm kind of optimistic that this is for sure to happen, but I would like to see somewhere, somebody, some organization take a leadership to make this happen sooner than later.
And I could continue from this.
Yes, please.
Yeah. Yes. So when we from the 6G flagship, when we brought together the experts for this joint vision building for the first time in March 2019, and then developed this first 6G white paper together with 70 experts, and we managed to reach consensus on the sustainability and a lot of other topics that many people brought up the same themes, same topics that are relevant. And then when we made this open call for experts to participate in the next round of 6G white papers, we had then 12 thematic groups in 2020, and they published 12 white papers on selected themes. And I was coordinating that process, and we had 300 experts from 100 organizations. And looking across these different themes, very similar topics were emerging even inside these different expert groups. Certain same kind of topics. So there is really a lot of consensus on what is new, what are the new topics. And now what we're seeing that I referred to earlier is that there are research papers then starting to address those individual topics and to develop those new technologies around those topics. So that's where we are today. And the next big step is then this ITU process of technology trends and vision building, and then requirements afterwards.
Yeah, this is Brian, if I may jump in. I agree with all that's been said thus far. I think it's very healthy to have the different activities ongoing in the different regions of the world. That way we can understand, different business models, different societal needs in the different regions, and then come together, as mentioned, within the ITU to put the ultimate vision together for the next IMT, develop those set of requirements, and then develop a common set of standards within 3GPP. So I think we have a very healthy ecosystem as we look at development of 6G and technologies that may focus within the next generation. Yes, there is going to be overlap. There's definitely, when you look at technology trends, you're going to see overlap. But looking at some of those different business models and societal needs and how those might differ from the regions, and then bringing those into the ITU vision and ultimately the 3GPP standards process. I think that's all healthy and ultimately will generate a stronger ecosystem as we move forward to the next generation.
Yeah, thank you for good answers.
I also agree with the previous comments. I think there is really interesting that there is a strong consensus on some of the driving forces. There is lot of exploratory research going on in the different areas and so on. So I think it's a good situation. It's really interesting what's happening now, I think. So I'm very positive.
Yeah, certainly plenty of good topics for research and good answers here. So let me then take a question from the chat. So Ricardo Ruska is asking that, do you think that new approaches to machine learning, keeping in mind the concern of privacy, such as federated learning, will be a key point in the era of 6G where privacy is increasingly important? Any comments to this from the panel?
Well, I think, of course, resounding yes to the word privacy. I think the data ownership and the data usage has already become a very prominent topic, even for 5G era in the ecosystem. And I think many regional or regulatory bodies are looking into the best means. And hopefully by 6G era, we will have a reasonable set of overall globally agreed guidelines and framework in this, because like some people say that going forward in the future, data is oil, right? Data is where all the value will be generated. However, who owns the data? Especially data involve individuals, or data involves specific enterprises. And so who owns it, who can manage it, and who can share it, and in what way? It's not a new question, but I don't think we are anywhere near a definitive complete answers yet. Okay, and the federated learning, yes, one of its value is to somewhat help to protect privacy in an AI or machine learning embedded system, but it's not the only answer. I think it will be one of important technical element in this pursuit, but there needs to be a lot more other.
Thank you, Chilin. There was at the very end there was a bit of connectivity problem, but I think it was just at the very end.
Okay.
So any additions to this from other panelists?
Well, I think that this topic of machine learning, when we did the white papers, I think it was discussed in every expert group, each of those 12 expert groups within their theme. So it's also a big cross-cutting theme, and researchers in wireless, like we are doing, like I'm doing spectrum management research. So of course now I'm looking at what machine learning can mean in the context of this technology development, this spectrum management technology development. I think that's what the community is now doing, what these new advances in machine learning and AI mean for their own research topics. And that's what we saw in this 6G white paper process, that this new technology development involves the inclusion of the new solutions and tools.
And concerning this kind of trust, privacy, security, so as we are here seeing from the use cases discussed, that more and more aspects of quite personal sensitive information digital gets into the network, and then it is, as also said here before by I think several of the panelists, so these aspects need to be as a very central design criterion for the 6G right from the beginning, to have a right approach to those, and including this machine learning.
Yeah, as we look at, you mentioned the trusted network. I think there's 4 important building blocks for trustworthy systems: security assurance and defense, service availability, secure identities and protocols, and confidential computing solutions. I think as we look at AI and ML, it's expected to have a major impact on future technology evolution as well as security, and is also a mechanism that can help in all of the 4 areas to build a trustworthy system. Thank you.
if we then move forward with the questions, so in the chat, Seppo Yrjölä is raising a question that was planning to be my next question as well. So how do you see the role of regulation and standardization changing towards 6G era?
Let me maybe elaborate a little bit more on what I kind of touched on about the SDO, the Standards Development Organization. It's actually based on our actual experience that we have seen. Some of you may know that I am also the co-chair of the O-RAN Alliance's Technical Steering Committee. And our alliance had set up a open source community jointly with NERSC Foundation. And so this open source community of O-RAN basically write codes following the technical spec that O-RAN Alliance's working group delivers. You would think that this is a very clear upstream downstream relationship, but actually not so at all, because in the process and with the experience of this CI/CD, the continuous integration, continuous development practice of the code development in the open source community, sometimes the work there actually moves faster than the speed that our working groups is delivering the related technical spec. So oftentimes we see a very valuable and powerful feedback coming back from the open source community that brings new ideas, new contributions to help direct or guide and also accelerate the technical spec that the working groups are working on. I think with this little experience, it's evidence that we could expect going forward in the 6G era, even our most traditional standard development organization, the most powerful ones, and I think I don't need to name it. Everybody has the same one in mind, probably. Will be able to benefit from this additional resource and expertise that open source community is bringing in, and I think there will be an interesting holistic mix. And as I said, also. With the SDO and the open source community's interaction, coupled with the element of the machine learning and the AI technology, I believe that the agility of SDO will be drastically improved in the going from beyond 5G to 6G era. So the impact, I think, will be obvious and will be more and more prominent as we move forward. Okay, I guess I'll leave the regulatory aspect to some other experts, maybe Brian, in this panel. So that's all.
Thank you. Who would like to continue?
I can comment. I totally agree. I think it's very important that the industry is able to benefit from the fast evolving IT tools and so on in open source and other places. So I think we are already today benefiting from it in the implementation and so on. But I think it's we need to find a way of avoiding a situation where the standard limits the possibility to use this fast evolving, because the standard is not evolving that fast. I mean, we agreed on an architecture for 5G, and that one is there for many years. Of course, we're doing enhancements, but we need to find ways of better using the fast development cycles in the IT industry. And I think this is really an interesting area for going into 6G and so on, trying to find ways of being able to do this. And I mean, just comparing, I think IT companies, they don't go, if they want to add a new feature to their system, they just do it. They don't go and propose a work item in a standardization organization, have a study period, do all the specification, and then start implementing this. So we need to find ways of moving away from that sort of thing, being able to do big changes in a more IT way of working. So I think that's a really interesting area. Thank you.
Thank you.
Let me just briefly touch on the regulatory aspect that Shilin pointed toward me. So, certainly regulators can continue to work with the mobile wireless industry to identify opportunities to advance technology and also balance regulation. Certainly regulation is different across different regions of the world, and we need to account for those different regulatory aspects. As we move to more densified networks, things like streamlining cell sites processes to put cell sites in places, developing more public-private partnerships, opening up access to more commercial use of exclusive use licensed spectrum and spectrum sharing paradigms. These are some examples of regulatory and industry opportunities. Regulators can help by promoting identified opportunities and just have a balanced regulation and management of mobile technology. Thank you.
Thank you, Brian.
I could continue a little bit on this regulation aspect, and especially the wireless communication. It needs the spectrum, the fundamental radio resource, natural resource, and that's managed by the national regulators. And there's a lot of international harmonization, and it's a reason why this technology is successful, that there is globally harmonized bands for mobile communication networks. And what we've seen in 5G is now, even though the bands are pretty much the same in different parts of the world, there is a lot of difference. Like in Europe, regarding the spectrum made available for 5G, the mechanisms, how that's done, who gets the spectrum, how much, in what kind of locations, we saw a huge divergence with 5G in terms of this introduction of local licenses. And the different European countries took very different approaches in what they made available. Some gave everything to the big operators, while others introduced some bands, some parts of the bands to local networks. But even these bands were different, and even the mechanisms were very different. So now we are seeing this divergence. It's just within the past a year or 2 years. It was not like that in 4G, but that is starting to happen in 5G, and it impacts the business pretty much.
Thank you. Then we have a question in chat from Muhammad Jehangir Khan about the role of visual light communication in 6G. So we ask to look at the recording of the panel to see our earlier discussion on the same topic during the panel time. And whereas then we could maybe look for additional questions, maybe appear in the chat, but before they come, so still a bit continuing on regulation-related topic with respect to spectrum. So we have already heard here in the panel about the increased interest towards higher frequencies, sub-terahertz. So how do the panelists see the relative importance of different parts of spectrum for 6G, and how do you see the time frame of getting these different spectral regions available? And any comments, for example, for the spectrum then between 6 and 20 that was decided at the early stage of 5G not being available for 5G. So how do you see that from 6G perspective? Any comments from the panelists?
I'll do a very quick one. I think that when we talk about the mobile communications, by default, the first thing is wide coverage. The second thing is high mobility. And I think in the very early days when millimeter wave was brought up for 5G's prominent consideration, there was already recognition that in terms of coverage, in terms of mobility, it will be much more challenging than below 6 gigahertz. And I think as the global community put in enough effort, we can see that the millimeter wave technology and system is slowly but surely becoming more mature. So when terahertz was brought up as the most prominent new part of the spectrum for 6G, I kind of have the similar feeling that maybe on our way from 5G to 6G, we'll be able to make millimeter wave technology reaching certain level of maturity to be widely deployed with time. And then I think terahertz will be a very interesting new opportunity, but I don't expect that bandwidth to be a widely spread applied in the early phase of the 6G. But it's worthwhile pursuing, definitely, to see how far we can go and how fast with that. Okay. I hope this is not very discouraging what I just said, but it's kind of my feeling based on experience.
Yeah, I tend to agree, Chi-Lin. You know, as we move in, you know, even the upper gigahertz into the terahertz range, you know, certainly that brings in the physics, right? We have the limited range, antenna physics, power dissipation, transistor noise, all those considerations that have to be brought into play. But as you know, the trade-off is you have the higher bandwidths for data-hungry applications like AR, VR, data kiosks, even broadband home connectivity, and the opportunity for new applications, as we talked about, sensing, you know, high-resolution imaging and things like that, and even the joint radar communications, you know, aspects of that. So. Yes, certainly, you know, as we look toward terahertz, you know, and the research going into terahertz, it's definitely an area that is of interest.
So some challenges for researchers.
Opportunities as well.
Yes.
Right.
So I think sorry, go ahead.
Okay, I'll just quickly add that already mentioned before that these generations of mobile communications, when spectrum was made available for them, those generations, that typically continues to be available decades after. The GSM bands, the 3G bands, they are being now used by the next generations, or partially still by those generations. So once you made one band available for the mobile communication, it tends to continue for that use. And every time the mobile community tries to get a new band to satisfy the needs, increasing needs. And this is the interesting part, that who then gets to use these bands. If you had licenses for 20 years, they expire, they often are renewed. Of course, depends on the country. And then adding more new band, and to whom do you give that and a new band? And at some point you will realize that when you get these higher bands, and if you only give those to some new local players, they don't have access to those what some other players have. So it's a really complicated setup of these different bands, and they are so like how they were divided and given to the different players in the different countries. It's really interesting to look at that, what the power balances really are, and how that should then evolve towards 6G. Every new band requires the sharing studies with those existing systems there, and whether they will now be cleared or not. I think there is a lot of room for research and in innovations in terms of this, making these sharing technologies that can facilitate the entry of mobile communication networks on a shared basis.
Thank you, Maria. So Gunnar, were you planning to add something?
Yeah, so I don't really have any opinion on the regulatory aspects and so on, but I mean, I think that I share the interest that I think the lower frequency bands will be important for 6G also, and I also think that this puts requirement on the 6G solution to be able to coexist with existing technologies. So I think that we need to support dynamic spectrum sharing. I think that there is also, of course, an interest in all kinds of sharing scenarios. We can see that, like network sharing, and there may also be spectrum sharing scenarios and so on. And of course, so I think these are requirements that will be put on the 6G solution. So I think that yeah, there has to be components there addressed. Yeah.
Thank you. So we are approaching gradually the end of the scheduled time for the panel. So 15 minutes left, and I would like to give opportunity, unless Chilini has something to add still to this, but I would also like to give opportunity for all the panelists to add any final statements or something they would still like to highlight. So Céline, would you then start as you seem to be going?
Okay, thank you. Definitely. I want to reiterate China Mobile's vision of 6G, because I think it's pretty crisp, which is digital twins and ubiquitous connectivity with the pervasive intelligence. And it's a brave new world that we have opportunity to pursue. And also it is for the first time, I think, the whole global community has already gotten so excited and ready to pursue yet another new generation, 2021. Because I remember that the first time, for example, when IEEE had a special issue on 5G was in 2014. I think it was a February issue of the IEEE Communication Magazine. But in comparison, we are right now at 2021. We already, as I said earlier, have multiple books that are already been published and announced with 6G on top of its title. And I believe we are much more mobilized and much better prepared to really deliver jointly a great 6G era to all of us. So that's all I have to say. Thank you.
Thank you. Any other panelists willing to share any highlights?
I fully support the view from previous speaker. I think that we are early, and it's a good thing, because it could make sure that we really get it right. We really understand the requirements and so on going into standardization much later. And I think also there is a lot of things to learn from the 5G deployments going on now, and learning from the ecosystem and so on, that we can kind of understand what are the areas that 6G should focus on and so on. I think that will coming a lot during the years to come now, that will influence what 6G will become later. Yeah, so that's basically my last comment.
Thank you.
Yeah, this is Brian. I think one of the key factors that we all have to keep in mind is that 5G is still early in its life cycle. It's still being evolved. It's still being enhanced. We have 5G advanced now being developed in the standards. So we have a long runway left on 5G and the evolution of 5G and the application of services on 5G systems. So I don't want to lose track of the fact that 5G is here and it's still evolving. And yes, there will be a 6G or an IMT 2030 that will come after this, that will look at some of the trends and predictions that we've talked about as we move into the 2030 timeframe. And some of those trends, as we talked about, going from connected humans to more connected machines. Some estimates we see, upwards of 500 billion connected devices, globally, as we move into the 6G timeframe. We've talked a lot about artificial intelligence, the openness and open architectures, the merging of the physical, digital, and virtual worlds, and a lot on the societal need for 6G mobile communications. But one thing, the other thing I wanted to stress is security. We talked a bit about privacy and trusted systems, but we need to make sure security is a consideration from day one as we evolve to the next generation. We're going to have these billions of connected devices, and many of those devices are going to have access to personal, financial, health, or other data that we talked about earlier that needs to be kept private. We'll see an increased trend in biometrics, more autonomous vehicles, digital trust and safeguarding data, as we talked about, and artificial intelligence. So we really need to take into account security as we develop it. And there's possible disruptors that'll happen in the 2020s that'll factor into 6G, whether they be technological, things such as quantum computing, brain-computer interface. There's some research going on in those areas, and just autonomy in general. We talked about different business models that need to be looked at as we move and progress the technology. And again, as well as those social needs, including self-sustaining neighborhoods, citizen science, and so forth. It's also good to understand what 5G will mean for the average consumer. We talked about the fully immersive experience, AI-enabled interactions, multi-sensory experiences, connected everything, collaborative robots, and Internet of behaviors. So there's a lot of advancement we're doing as we progress 5G, and a lot of opportunities as we talked about for 6G. And I think it's going to be some really exciting times ahead. Thank you.
Thank you.
And I could go back to the whole theme of this whole event that we are organizing towards sustainable 6G. And sustainability has many angles, and one triangle of sustainability is this triple bottom line of social, environmental, and economic sustainability. So considering those different aspects and really looking at their intersections. So what happens when you combine the different viewpoints? And that's where these real innovations can be made. And continue on what Brian was saying, that there's a lot of business-related aspects. And there's a lot of need to look into these business models, business ecosystems, this changing business landscape. Also the technology development, it's such a huge theme that there's a lot of different elements in that. And then the third part is the regulation. So this triple part now of business, technology and regulation, and how they are linked, how they influence each other, how technology development influences regulation or is influenced by regulation. So looking at these triangles, how these different elements impact each other and how they should be done for 6G, what is different. And what I see different really is this real consideration of sustainability.
Thank you. This is an excellent statement to the end. Actually, when I was about to say that we are ready to end a couple of minutes early, which is not a bad habit, but we still have actually one question that we should then certainly target. So Patrick Rugland is asking that, does this early interest in 6G risk pushing the expectation to accelerate the timeline for 6G? Any comments on this?
I'll jump in. I think in a way, when we talk about the timeline of the different generations, it's I think the word artificial is not quite that good, but maybe it's a more man-made factor in the sense that the technology evolution is a continuous effort. It's not like something would just jump out all of a sudden, create a great discontinuity, so to speak. And actually, we have seen many times that the originally targeted for the N+1G technology applied to energy. Case in point,
unfortunately, we have some connectivity problems once more. Concerning the timeline for 6G,
I think since we have the 6G early. Do we have a connection problem?
Now we could.
Hello, can you hear me?
Yes, we can hear your audio now. Fine.
Okay. Just let me quickly finish up. I think since we have started this early to explore all different aspects of the 6G consideration, I would not be surprised that some of the ideas that initially was conceived for 6G system will get applied into the 5G, either in the beyond 5G stage of the tech standards, or being applied directly into the ongoing 5G deployment globally. So to accelerate the timeline for 6G per se, I think as far as the standards milestone and timeline right now, we can see that probably somewhere around 2026, the early stage of a study item of 6G may emerge. And then maybe as early as 2028, we can expect the first stage, the phase 1 of the 6G standards being shaped up. I don't think that timeline will change or be accelerated that much. It's a matter of what you consider that it's belongs to the bucket of 6G standards, or is actually considered as part of the continuous evolution of the 5G. I think more and more going forward, the continuum phenomenon will become more prominent. I'm not sure if I answered this particular question, but that's my sense of reading about the global development, both going from 5G to beyond 5G and the 6G stage. I hope Patrick is okay with that.
Thank you, Jirin. And
can I just jump in for one moment? I wouldn't characterize it as an early interest in 6G. If we look historically, you know, a new IMT has occurred roughly every 10 years. So we are just in that early cycle of the next 10-year, you know, for the IMT 2030. And when you look at the time it takes to do research, the time it takes to do the initial vision and requirements, and then the standardization process, I wouldn't characterize it as early interest. I think it's in a natural timeline looking at the next IMT. And as Chi-Lin mentioned, you know, we can't lose sight of the fact that, you know, there's still 4G evolution going on. There's 5G evolution going on as we develop the next generation of 6G. So I don't think there's going to be an expectation to accelerate that timeline at all. We're just in that natural cycle of development. And as mentioned, the standards for that next G will start in the latter half of this decade. Thank you.
Thank you, Brian. So I think that in this timeline question, so Jirin was showing, for example, the world map of the different activities, different regions. And as far as looking at the timelines that these different activities are bringing up, so they are quite much aligned with what has been said here. So expecting the standardization around halfway through the decade, and then commercialization towards the end of the decade. But now we have run out of time, and maybe if there is just a very, very brief burning comment still from Maria or Gunnar, doesn't seem to be so. So okay, so then we are at the time of closing the panel. So thanks a lot to IEEE PMRC 2021, the organizers of having us here today. Hope we have brought then good perspective on global view on 6G to those attending. And yes, thank you all for the questions. Thank you for the panelists. So I guess we are closing the session.